Okay. Second, I thought the sound wasn't working. Um, so when we have an equation, you can always try graphing it at fine domain and range. That's not always the best plan. So we're going to find some ways to kind of cheat that. So this first part is not the one you're going to see right away, but it will come up again. So the domain of a function consists of all values for which the function is what we call defined. For our uses, defined means that each input in the function will produce a finite number in the output. So what that means is that if I can put an X in and I can get a Y out, it's defined. Undefined means I put an X in, I don't get a Y. So what it means to be undefined is if I input an X, either the output Y is non-existent, or itself is undefined. So this first case here, when we're talking about roots, these are going to be cases where it's just simply non-existent. So for example, if we have this, sorry, fx is equal to the square root of x minus 1, 2 is in the domain, because if I do f of 2, I just replace x with 2, I get a square root of 2 minus 1 for the square root of 1, which is 1. So if something came out, it was defined. In that other case there, let's say we put in 0. So f of 0 would give me a square root of 0 minus 1, which is a square root of negative 1. And if you remember, you cannot do square roots of negative numbers. This makes this one undefined. We'll also have cases that are non-existent, but this kind of helps us this sort of, there's certain things that just are not going to work. They're not going to output anything for us. So I'll put that little note here. We can't do square roots of negative numbers. In the real numbers. So what we're doing is everything we're doing is in real numbers. At some point, we are going to move into something called complex numbers. In that case, these things are not undefined anymore. Just as long as we're in the real numbers is what we're working in right now, that is undefined. For the real numbers, we only have square roots of positives and reals. Like I said, we can only do square roots of positive numbers in reals. For the function g of x equals square root of x, the domain is going to be any x value that is 0 or greater. Because I can do the square root of 0, I can do the square root of 1, I can do the square root of 2, I can do the square root of 1 billion. That's fine because those are all positive or 0. So let's say we want to find the domain of f of x equals, so square root of x minus 1. So we already found out that 0 is not in there. So what we know is that this part in here has to be greater than or equal to 0. Because what I said back here. I said back here that I have the square root of x, x has to be greater than or equal to 0. Just went back too far. So what we're saying is anything that's in that, under that radical sign, under that square root, has to be greater than or equal to 0. Which is what I do down here. So since it's greater than or equal to 0, I'm just going to solve for x. So we just add 1 to both sides. And we get x is then greater than or equal to 1. So the domain of f is going to be all my x values that are greater than or equal to 1. It's your solution page. So at this point, take a little break and work on your number 5. So A, B, and C. I think it was just A, B, and C. Let me check quick. Yes, just A, B, and C. So for the first one, what we need is that negative 2x to be something that is positive. It means it has to be greater than 0. So for this to occur, that means that my x's here would have to be negative numbers. So my x's would have to be things that are below 0, because 0 would work because square root of 0 is 0. If I say x is 1, then I would have a negative 2 in here, which I can't do a square root of. However, if x is negative 1, so it is a negative number, negative 2 times negative 1, well, that'd be positive. So in this case, it wasn't so much as trying to solve an equation, it's just sort of thinking about it, that if I have that negative 2 there, the only thing that's going to turn into a positive is making sure my x's are negatives. So my domain is just x values that are less than or equal to 0. For G, we have to make sure that 3x minus 6 is greater than 0. So we just solve the inequality to figure out what x would have to be. And we see that as long as x is greater than 2, that should satisfy the conditions to have solutions, meaning it's going to be in the domain. So all I'm doing is just guaranteeing whatever numbers I put in for x is going to keep what's in that radical positive. And then this one, I have 9 minus 2x is greater than or equal to 0. So we're going to solve that again. So we're going to add 2x to both sides just to move it out of the way. So I have 2x is going to be equal to 9. Or sorry, 9 is greater than or equal to 2x. Got something popping up on my screen here. Oops, just a second. Sorry about that, something kept popping up. So what we have here, like I said, is 2 is greater than or equal to, or sorry, 9 is greater than or equal to 2x. Divide both sides by 2. So sometimes you have fractions in here, but 2 has to be something. So you have 9 halves is greater than or equal to x. Or if we flip this all the way around, what we're saying is that my x values have to be less than or equal to 9 over 2.